Okay, I'm Alexandra Ferland, and well, I guess I'm a graduate of UMass. This is my last night as an undergraduate, so celebrating here.
Congratulations!
Thank you.
Hey, that's a big deal.
Thanks. Yeah, and my study was in natural resource conservation, so my project was primarily focused more in the environmental kind of direction. And I was actually taking an invasive ecology class with Bethany Bradley, who's a professor at UMass, and kind of sparked my interest in invasive ecology. So my project kind of geared towards that, and Charlie has actually previously done a kind of similar, so it kind of all worked together to kind of do this project. So basically, we had a public lab balloon mapping kit. So we had a balloon that was probably 6 feet in diameter, yeah, huge, to fill with helium.
Well, you can see in the picture, right?
Yeah, right in the bottom right. And we had a 3D printed camera rig to attach to it. It's the one right next
Which
to it.
I have in my car outside. I forgot to bring it in.
So
So if anybody wants to see
after.
it, we'll get it after.
It's pretty cool. And you can't see it, but on the top there's a timer so that the cameras would be set to take photos at the exact same time. Because one of them would be an infrared and one of them would be a true color RGB camera. And well, we have some issues with those two cameras, but that's could be discussed later. But so we were kind of looking for a low cost, easy way to do invasive mapping that anyone can kind of go out to do. And we went to Westfield, Massachusetts, actually, because the conservation coordinator there asked us to come because the people who use Brickyard Ponds, which you can kind of see right at the top, for their fishing, kayaking, going on boats and everything, are unable to because the water chestnut, which is an invasive species, has just taken over the ponds. And like many aquatic invasive plants, water chestnut forms these huge dense mats over the water, which pretty much ruins any chance of getting through, which hurts the water ecologically, but also it hurts the community economically, which is a huge problem because it's also extremely costly to remove it. To remove water chestnut, you have to physically go into the water and pull up all the seeds, and it has a fast reproduction rate, so it's once it's established, it's really challenging to get rid of. And these ponds are popular for people to go, and so they've been complaining that they can't go out there anymore. So we went out there to do mapping for them, and you can see here, these are two of the images we got with our infrared. In the circle is us, and we were about 300 feet high because we actually had restrictions, which is kind of an interesting public policy aspect to this because we were near an airport. So we couldn't go any higher than 300 feet with, what were the
The F-16.
F-16s
We were near the Barnes National Guard base. So we were on the phone to the tower
to kind of warn them that we were going to be there.
We have a balloon in the air.
Yeah, so it was kind of like a whole nother kind of interesting portion to the project that you don't really expect when you're just going out to fly your balloon and try and help the community. But so that kind of was an interesting part. We unfortunately don't really have any of our RGB images because we had technical difficulties with it our first time out there. And then the second time we actually went out in the canoe into the ponds to fly it, but we weren't expecting as windy as it was, so our camera unfortunately took a few plops into the pond and was destroyed. So we have no images, but learned a lot from that. So that was a good experience. And two people I actually was working with who unfortunately couldn't be here tonight, they had made this poster because they're in Charlie's GIS class. So on here you can kind of see they use Public Lab has this almost like an application you can use called MapKnitter. So they use that, and you can see it here and up there where you can kind of knit your photos together. It does it pretty much like for you in a way. You kind of have to overlay them, and then that way you can place it onto your images. So you can, because we have a bunch of weird angles, so it's helpful to use that to kind of be able to overlay them and kind of, I guess, just visualize it. And we also, while we were out there, we used a what is the georeferencing?
A GPS?
Yeah, can't think of the word, the GPS to mark the locations of where we actually saw water chestnut. Unfortunately, none of the images overlaid onto where we saw it because we did go kind of later in the season, so a lot of it had died off. But
actually, can I just say one thing?
Yeah.
There actually are a couple that we got in the images. So what we were trying to do is see what the light spectra, the spectral data will tell us if we could identify water chestnut based on the infrared and the true color data.
Yeah, and you can kind of see that down here. They were able to do the Photoshop, and I believe from it they said that they weren't really able to, and I think that's kind of due to the fact that we didn't have that many water chestnuts in the image to see. So I think if we went earlier in the season to do this project, I think the results would have came out a lot differently, but overall, I think it was really awesome to do. And we got to go to the middle school, which Christine mentioned, which was a lot of fun for me. And we even got to work with Amherst flying our balloon near Bertucci's to get an overshot of the new construction that they're doing. So the balloon's proven to have a lot of applications, and it's been a fun semester doing it.
We've had a lot of adventures, that's for sure.
Yeah.
So thanks, Allie. And any questions for Allie before we bring up Brett? Yeah.
Do you reuse the helium?
Yeah, we actually kept the helium in it, and we actually kept it in the first floor of Holdsworth, just kind of in the back, because helium actually proved to be one of the most costly portions of our project, getting it and filling it. So we tried to keep it in as much as possible, but we did have to deflate it once or twice.
And what was interesting to me about this is that Westfield Conservation Commission asked us to do this, and also the town of Amherst asked us to do this. This is really low-cost unmanned aerial vehicles, and there's a lot of debate over the use of these in the United States. And so it was interesting to me that the actual local government agencies were interested in this. We were very we were very concerned about flying over Bertucci's and the local, the private people, and so we were contacting them to make sure that they were okay with this. But next year when we do this class, what I'm interested in doing is actually bringing in some students that may be interested in this technology, but also will be interested in the public policy issues around it, so that there would be somebody doing, maybe next year, a quadcopter remote sensing, but then also some other student doing research on what are the policy issues about this, what should we be thinking about. And John Karras isn't here of Smith College, but they're already thinking about these issues. So we've got a community in the Pioneer Valley that is interested in this. So I'm excited about that for the future, but yeah.
So you talked about the true color camera. Was that different than just a regular camera? Were you able, if it had worked, were you able to get, sharp spectral bands out of it?
Well, we had the near infrared, and then we just had like RGB, which would be like a regular type of photo.
And if you had been able to collect data from the RGB and the near infrared, what kind of analysis would you have done with the four bands to help you identify chestnut?
Well, we were kind of hoping we'd be able to overlay them a little bit and get more of an image of where we actually physically could see the water chestnut, so we would know the exact location. Luckily, we got the GPS coordinates, but as you could see, we missed a lot of portions. So if we had the overlay, we'd be able to kind of visually see it. And
UMass has another course that's on remote sensing, and so the idea would be if we can connect the GPS point to the pixel, and then you have the four bands, infrared, red, green, and blue, we could do possibly a supervised classification using those four bands, those four cells of data. And that was kind of the plan, but then our camera went into the pond. So we learned some practical challenges of this kind of work, and we're learning. But yeah, that was a good question. That's where we want to go with this. So yeah, thanks, Allie. So Brett, are you ready?